Welcome back to the channel. Today, we're exploring one of the sun's most powerful and fascinating phenomena, solar flares. These explosive bursts of energy aren't just spectacular to watch. They also have a huge impact on our planet and technology. So let's dive into the history, science, and some really cool facts about solar flares you probably didn't know. What exactly is a solar flare? Solar flares are massive bursts of radiation caused by the sun's complex magnetic fields. Picture the sun's surface filled with magnetic field lines that twist, tangle, and sometimes snap, releasing an enormous amount of energy in the process. This energy blasts out in the form of light, X-rays, ultraviolet rays, and energetic particles. They happen in active regions around sunspots, those dark spots you sometimes see on the sun's surface in images. The history of solar flares, archival images and drawings. The story of solar flares begins in the mid-19th century. In 1859, a British astronomer named Richard Carrington was observing sunspots through his telescope. Suddenly, he witnessed a brilliant flash of white light on the sun's surface. This was the very first recorded solar flare. This flare, now called the Carrington Event, was so powerful that just 17 hours later, Earth's magnetic field was violently disturbed, causing telegraph systems to fail and spectacular auroras to light up skies around the world. As far south as Cuba and Hawaii, scientists today consider the Carrington Event the strongest geomagnetic storm in recorded history. If something like this happened now, it could seriously disrupt power grids, satellites, and communications worldwide. How solar flares affect Earth. When a solar flare blasts particles toward Earth, it can cause beautiful auroras, sometimes visible far beyond the usual polar regions. These glowing curtains of green, red, and purple light happen when charged particles collide with Earth's atmosphere. But solar flares can also be dangerous. The burst of energy can interfere with GPS signals, cause radio blackouts, and even damage satellites orbiting our planet. In extreme cases, they can overload power grids and cause blackouts, like what happened in Quebec, Canada in 1989. Solar flares versus nuclear bombs. Here's a mind-blowing fact. A single solar flare can release energy equivalent to 1 billion megatons of TNT. That's millions of times more energy than the most powerful nuclear bomb ever tested, the Tsar Bomba, which was 50 megatons. Imagine the scale of power coming from a tiny spot on the sun's surface. Solar flares and space exploration. Solar flares are a major concern for astronauts and space missions. The energetic radiation from flares can be harmful to astronauts outside Earth's protective magnetic field. That's why space agencies carefully monitor solar activity to time spacewalks and protect equipment. NASA's Parker Solar Probe, launched in 2018, is actually flying closer to the sun than any spacecraft before, collecting data about solar flares and the sun's corona to help us understand these fiery outbursts better. The sun's 11-year cycle. Solar flares don't happen randomly. They follow an approximately 11-year cycle of solar activity called the solar cycle. During the solar maximum, the peak of this cycle, flares and sunspots become much more frequent. The solar minimum, on the other hand, is a quieter time with fewer flares. This cycle helps scientists predict when Earth might experience stronger space weather effects. How we detect solar flares today. Modern technology gives us incredible ways to observe solar flares. NASA's Solar Dynamics Observatory, SDO, constantly watches the sun in multiple wavelengths, capturing high-resolution images and videos of flares as they happen. The Geostationary Operational Environmental Satellites, GOES, also monitor solar X-rays, alerting scientists to dangerous solar storms that could affect Earth. The power of the sun. The sun is a fascinating and powerful star, and solar flares are just one way it reminds us of its immense energy. From the first flash observed by Richard Carrington to today's high-tech satellites, we're continually learning more about how these solar explosions shape our world. If you enjoyed this deep dive into solar flares, please like, subscribe, and leave a comment below. What space mystery do you want us to explore next? We're always excited to hear your ideas. Thanks for watching, and see you in the next video.